Hello college algebra student, this video is for chapter 3.1. Continue with function notation, and in this particular part we finish how to evaluate a function if given an x value, and we write it as f of something. So this should be g, I think. So I have some typo here. This will be g. I'll fix it in the notes. So if I am to do f of something, I plug it in, right? So what happens is if I have f of, I have this, this is f, let's say this is f of x is 2x squared plus 1. I can certainly do f of 1, right? So that means my x is 1, I put here, but I only have one placeholder here, so it's 2, 1 square, root times 1 square, plus 1. So that would be 2 plus 1, and that's 3, right? But if I can actually plug in a variable a, what would that be? It will be 2 times a squared, because like this is just the input. Whenever I see x, I put here plus 1. But I can add this because they are not like terms. So it's 2a squared plus 1. So you can see this placeholder, this x, can be anything, including x itself, right? So it's just be 2x squared plus 1. And I can plug in actually two variables by saying I want to plug in x plus h. So this is a particular expression called a difference quotient. Difference quotient. So this is a special name for it. It will be used extensively in calculus. So we would want to talk about this. So this just tell us that I want to plug x plus h in the function, and then subtract by plugging in x and divided by h. So it's a difference of something divided by, and they divide each other, so it's called difference quotient. And in calculus you will notice that this actually gives us a slope. So so we'll just do it. So in this particular function, my placeholder is x. So you imagine 2 of something square plus 1, right? Whenever you want to use it, it's like that. So in the first part, I would plug in x plus h. So it'll be 2x plus h square, because that's what the function is about, plus 1. And then I minus f of x. This is the whole f of x, right? So I parenthesis it though. 2x squared plus 1. Please remember to parenthesis it. If you don't, then you would just be subtracting the first part and add the second part, which is not what we want, and divide by h. So the difference quotient is, this is f of x plus h minus f of x. And then for x plus h squared, in order to combine like terms, you have to FOIL it out. So x plus h squared is x plus h times x plus h, right? So it is not x squared plus h squared. You have to FOIL. So that would be x squared plus xh plus xh plus x squared. So that would be equal to x squared plus 2xh plus h squared. So it's very strange. It has two variables, but you can do it. So, but then it says a 2 here. So a 2 of x squared plus 2xh plus h squared plus 1. Now I'm going to distribute the negative 1 to, we're not distributing the whole thing in the front. If there is a subtraction here, that means negative 1. Okay. Plus 1 minus 2x squared minus 1, because negative 1 times 1 is negative 1, divided by h. So we almost can do combined like terms now, but I want to distribute the 2 first. So it'll be 2x squared plus 4xh plus 2h squared. So that's what you do in the beginning of calculus. You would be able to process things like that. A lot of terms of combining like terms. Now divided by h. So are there any terms that are like terms? Oh, of course. 2 minus 2xh, 2x squared minus 2x squared plus 1 minus 1, this cancel. So that would equal to, so let's continue here. I have some space here. So it will be 4xh plus 2h squared over h. Now, if I divide this, I need to factor, right? So I can divide them individually. I have to factor the h out. So actually 4x plus 2h. Yeah, there's more thing you can factor out, but my intention is just to cancel the h. So I factor it, so can cancel the h. Then now it's cancelled. My answer is 4x plus 2h. That's the answer. Okay, so you will need to know how to do this. This is a required part of 3.1, a very important part of 3.1, especially if you are going to do business calculus or apply calculus. Okay, so the next part is evaluate a function when you have a formula. Write a function out if you have a formula. So let's go over how to do it. If someone gives you a formula, oh, there's so many formula out there. You say a good example would be the area of circle, right? A equal to pi r square. I can change it into, okay, if I know r, I can find a, so I can write it as a of r, right? A of r. That means this is the name of the function. If I plug in r, I get the area, which is pi r square. So this is one way of writing a formula into a function if you already have the variable that you solve. But sometimes the variable is not what you want to be. You want to solve for r as a function instead of a as a function. So sometimes you have to write the formula and isolate the output variable. So in this case, our output is a, and my input is r, so it is already done. But if my output is r and my input is a, then I have to solve for it and then use the function notation to write it. So let's look at it. First example, write function f as f of p as a function of n. So you want to write function f of p as a function of p as a function. No, I don't know why. What a function for, I think it's for for p as a function of n. So I want to write a function of p of something, right? As a function of n. So the function of, I think maybe f is just a name, so maybe I'll just erase it. Okay. So they want f of p. No, I think they want p equal to f of n. P as a function of n. Yes, p as a function of n. So n is the input and p is the output. So, but I don't have p equal. So how can I write p equal? So you would say, well, I isolate p, so minus 2n, 6p is 12 minus 2n, and you want p equal, so you divide by 6, so p is equal to 12 over 6 is 2 minus 2n over 6. So that means I divided by 6 on both sides, so it is 2 minus n over 3. So this is the formula, but if I want to write as a function, then I will say p is equal to f of n equal to 2 minus n over 3. Okay, like that. It's a function of n. So someone has a function c of n. It represents the cost of catering for n guests. That means you plug in the number of guests and you will use this function to give you the cost. So what's the meaning of c of 12 equal to 180? Okay, remember, n is n guests. C of n is this function number, this function notation represent the cost of catering n guests. So C of n would be 12, right? If I have C of 12, that means n is 12, that is 12 guests. N is number of guests. And what would C of 12 be means? C of 12 is either the cost of catering for n guests. In this case is 12 guests. And that is 180. That means you need to spend $180 to cater for 12 guests. Oh, this is what we were talking about, circle formula, but it is not area. Is circle is a function of circumference. So we know a formula for circumference is equal to 2 pi r, right? 2 times pi times r is equal to circumference. So, but we want to write the radius as a function of circumference. So we want a function of circumference. A function of circumference. So this is the input, and we want it to have the radius is equal to that. So let's solve for r equal. So use this to solve for r equal. So r would equal to, you divide it by 2 pi on both sides, obviously, right? So that would give you r equal. So c over 2 pi. So this is how you calculate r. You will input c, and you will get 2 pi. So we'll say f of c is equal to r is equal to c over 2 pi. Okay, so express the meaning of r of x pi. So or actually f of x pi. So sometimes we don't call it a different name. We call it r of c also. Some people use the same thing as the name of the function. So r of x pi means when circumference is x pi. You plug in x pi. The radius is, because the function itself gives you the radius, is 4. So usually we would have a radius and find circumference, but this is reverse. You have a circumference, and by plugging in 8 pi over 2 pi, it becomes 4. So the radius is 4. One more. So given the formula x minus 3y cubed equal to 0, express y as a function of x. So we want y as a function of x. So y have to have been by itself equal to negative x. And I divide negative 3. So y cubed would equal to x over 3. Because if I divide negative 3, divide negative 3, so I have 9. And then I need to y equal, so I do cube root, right? X over 3. So this would write it as a function of x. So I would say this is called y equal to f of x is root of x over 3. Or you can write it this way. Okay. So the last part is called a toolkit function. So there's a lot of small functions that can be used to make up other functions, and we call them toolkits. So there's a lot of them, and I'm going to this is very blurry in the notes. So I'm going to go over to the so you can look at it. So there's how many? 9 of them, I think. The first is called a constant function. It's y equal to c, f of x equal to c. The second is f of x equal to x. So it looks like that if you graph it. The third is f of x equal to absolute x. It's like a V shape. We call it the absolute value function. The fourth is a quadratic function. F of x is x squared, is a parabola. So these are the points that you plot. And the fifth is f of x equal to x cubed, is called a cubic function. It's like that. You graph it. This is the point that is available to graph it. And then the sixth is a reciprocal function. So 1 over x. And the shape is like this, and this is the table. And then what was the 6, 7 is the reciprocal square. 1 over x squared. It turns out that it's like the two branches go up to the infinity. And these are the points. 7, the square root function. Like this. And then the